So in this second half of 4.2, we are going to finally get to graphing the quadratic functions from standard form. So we have standard form. How do I do a graph? So we have already graphed it from vertex form. And of course, two things to consider with any graphing. You always need to know, number one, where to start. And you always need to know how to move. Now, if you don't know either of these, then you can always make a table of values. And then once you make the table of values, connect the dots. The problem with making a table of values is when you make a few points, you don't know if this line should be straight or should be curved or should be bounced or what. So a table of values has its weaknesses. So today we're going to figure out how to start and how to move from standard form, which we've already done with vertex form. So let's take a gander here. Let's walk through. So we're going to graph a function of the form. So here's my standard form right here. Remember that this is called my... All right, so like I was saying, sorry about that. This one is called my quadratic term. Quadratic term. This is our linear term. That's my constant. Order does not matter, folks. We're not saying the first, the second, and the third, unless it's in standard form. What we're saying is find the square, and the whole thing is your quadratic. Find the power of 1, that whole thing is your linear. This one right here is simply your constant. All right, so steps 1 and 2 are exactly what we did yesterday, only we're going to add it over here to our graph. So the first thing is I'm going to identify my A here, which is positive 1, my B here, which is positive 2, and my C here, which is negative 5. Okay. To find the axis of symmetry, remember that we are going to take our formula x equals negative b over 2a. And I'm going to substitute in my b, which is 2. So that goes in the numerator. And a goes in the denominator like so. And I'm going to simplify here. Negative 2 over 2, negative 1. Now we have that value, so I'm going to go back to my original function, which is y equals x squared. But I'm going to substitute in, instead of x, I'm going to substitute in my negative 1. So my negative 1 is going to go in there. So after you finish that up, we see what our vertex is. We see that our vertex is negative 1, negative 6. Remember that I took the x value here and the y value here to come up with my vertex here. Now, before we even begin to plot, we have to try to make a sketch because we want to remember where our graph is going to live primarily. So we know that my vertex is negative 1, negative 6, which is somewhere in quadrant 3. Next, I know because of the a being positive 1, I know that this is going to open up. And it's going to have the standard pattern of slope change. So remember, when I say slope, I mean that quotes slope. So I'm actually going to change number 4 from plot the y-intercept, which can actually help. But here on number 4, I'm going to say use pattern. Now remember that pattern is the slope goes up 1, right 1, up 3, right 1, up 5, right 1, etc. Or, and let me actually throw an a in front of that, whatever a is, it's going to multiply that pattern out. So I do know that I'm going to spend my beginning in quadrant 3, but I am going to use all the quadrants. So I'm going to probably make a standard graph such that it where the bullseye is in the center there. So here's my xy. I'm going to put a few numbers out just to establish scale, like so. And I know where my first point is at negative 1, 1, 2, 3, 4, 5, and 6. So I'm right on the edge, which is nice because I don't need to go down at all. I might wanted to have counted better and just have a little bit of buffer underneath, but this will work sufficiently. Okay, now since my pattern, since my A is 1, my pattern is going to be 1, 3, 5, and I'm going in the upward direction. So I go up 1, right 1 to here, and I'm going to mirror that on the other side of the axis of symmetry. Now from that point, I'm going to go up 3, right 1 to be at this point, and I'm going to mirror that over there. And I can even get the 5 here. 1, 2, 3, 4, 5. So my new point is there. And I'm going to mirror that. And of course, this is where your skills come in. Can I graph this decently, the curve decently? Like so. Feel free to erase when you make a mistake because it is inevitable. And this is my graph. Just to review real quick, the first thing we found was the axis of symmetry. And some people like to have that axis of symmetry in. You do not have to put it unless it says specifically label the axis of symmetry or include it. But here is nice to have it because I can see how the points reflect across that axis. Here and here, here to here. So having that set up might be helpful. Next, we substituted into the function to find my vertex. We plotted that. I also used the A to figure out which direction I'm going so I can make a sketch. Then I set up my coordinate plane and use the pattern A times 1, 3, 5, etc. And just plotted it out. Remember, the reflection there means I only have to do the pattern on one side and just reflect it on the other. Our next skill that we want to do is to be able to convert from one form to the other. So we touched on this quickly yesterday without graphing. So we're not graphing. I just want to convert from here to the more common one that we've seen thus far, such that A times x minus h plus k. So notice the three things that I need. I need to find out what my A is. I'll give you a hint. You just point to it. I need to find out what my h is. That one's straightforward. And lastly, I need to find out what my k is and just substitute those in. So the only real calculation we have to do is, since this is my vertex form, all I have to do is find the vertex form, because right here is already my A. My A is already there. So let's identify the A and the B real quick. A is negative 2. B is negative 4. I get that from here and here. Remember that these can be considered, it can be a mental situation. You don't actually have to write it out. But if you find it helpful, I encourage you to be doing it to stay organized. Now to find the vertex in step 2 is exactly the same as we did before. We say x equals negative b over 2a. Remember, write it as we're doing it so that you're always building in review. So the a goes in the denominator, the b goes in the numerator. Now we have to pay close attention, is I see a lot of negatives happening here. A double negative is positive, but I still am left with a negative. So my final result is still negative. 4 in the numerator, 4 in the denominator, negative 1. Now continue. My original function is negative 2x squared minus 4x plus 6. And I'm going to take the negative 1 and substitute it in here. Okay, now finishing up here, double negative, so negative 1 times negative 1. I'm squaring first. Don't do these two negatives here. Coincidentally, you might get the same result, but still do these ones first. So this one becomes a positive 1. So I'm going to go ahead and write that down as a positive 1, plus the 4, plus the 6. So negative 2 here, plus 4, plus 6, which is positive 8. So there's my vertex. And remember that my vertex has special letters. This one is called my H. This one is called my K. So all I have to do is take my A, H, and K and substitute it in. So I'm going to write down the vertex form just so that we refresh ourselves. Y equals A times parentheses X minus H squared plus K. I forgot that square above there. Sorry about that. All right, now we just substitute things in, paying attention to our double negative in a second. I do put a, is it a 2? Go back and check that. The A is negative 2, so I have to put a negative 2 down. Watch out what happens here. I put a negative 1 in for H. But Swenson, doesn't double negative be positive? Isn't it positive? Yes, it is. I'm just going to go ahead and substitute it now so that you see what happens. So my final answer is this. Y equals negative 2 times quantity x plus 1 squared plus 8. You and a friend are hiking in the mountains and you want to climb a ledge that is 20 feet above you. The height of the grappling hook, that you throw is given by the function because, of course, you're a hiker and you know this. That h equals negative 16t squared plus 32t plus 5. What is the maximum height of the grappling hook? And can you throw it high enough to reach the ledge? So the first question we tend to ask is, well, what is this whole formula thing? And the answer is, well, there is logic behind it, but there's no need really to pull too much behind. Let me break it down just a little bit. You don't need to know this, but I just want to show you that it's logical. Number 5, this is the starting height. So I'm throwing it from 5 feet. So maybe I release it at my shoulder, something like that. 32 here tells you how fast you're throwing it to begin with. So I'm tossing it at 32 feet per second. And negative 16 is gravity pulling back. So here's me starting at a certain height, tossing this thing up, and fighting against gravity. So the negative 16 is the downward pull, right? This was upward, this is upward. So I want my height, I'm trying to see if I can get it up to 20, all the way 20 feet there. So what do I need to do? Well, remember that if I were to sketch it, which I don't need to, but here's my 5, and I'm throwing this grappling hook up like this, up to a ledge, hopefully that's somewhere here, right? So I'm trying to make it up that high. So I want to know, ultimately, does my vertex reach? I'm checking to see if my vertex will reach it. Will the highest or the max, will the max be up to the 20 feet there? So what do we have to do? We're going to find the vertex. So x equals negative b over 2a. We know what a is. A is negative 16. We know what b is, which is how hard I throw it to begin with. So, of course, this will not tell me necessarily this will tell me how far it is until I get to the max. That's what the h here is going to be. It's going to tell me how many seconds it took to get to the vertex. How do I know it's seconds? Well, my background information tells me that the t means time, although it doesn't say in the equation here. All right, so now we start substituting in. Remember to have the negative, to have the 2. I just throw the parentheses down like this. Now I'm going to throw the negative 16 in the denominator and the 32 in the numerator. Double negative here becomes positive. 32 over 32. So nicely, it gets to 1. So how do I interpret this? You don't have to yet, but I do want to bring this back into the real world. It takes 1 second to reach max. After I toss it, 1 second later, I have now got to the top of my parabola. Now we're going to plug that back in. So x equals negative 16 times t squared plus 32 times t plus my 5. And so my 1 second goes in there each time. Negative 16 plus 32 plus 5. And so here I get 21. So 21 feet high. So I didn't answer the question yet, though. So let me go back and make sure that I have answered it. Can you throw it, the grappling hook, high enough to reach the ledge? The ledge is 20 feet. I can toss it minimum of 20, or the maximum of 21 feet. So the ultimate answer is yes, by 1 foot. So I still have a little bit of grace period there.